Hi everyone. Today we are hosting another part of the course Scientometrics using Cielo in BigQuery by Alysson Fernandes Mazoni, who is a researcher at the State University of Campinas. As Alysson mentioned last time, today we'll have a more hands-on session, I guess. So feel free to participate, ask questions, open microphones. You can also use the chat box to comment. So thank you all again, and we are ready to start.
Thank you very much. I am still opening all the files. One more. Okay, then I'll share my screen. You're hearing me well, right?
Yes.
So, just a quick recapitulation of what we did. We last session we have talked about data programming tools for scientometrics. So I introduced you to our experience and using Google Cloud infrastructure as our main tools, and I showed how it works. I made some discussions on how you can deal with it, how you can create your accounts. It's not free too in the sense as infrastructure, but it's the cheapest thing we have at the moment. I mean, to be completely honest, its competitors have similar prices, is slightly higher in one thing, slightly lower in other things, but they are mostly the same, like Amazon. And you also have Alibaba Cloud, but Alibaba Cloud does not have such a nice interfaces as of yet. I suspect someday they will reach the case. Then I have started talking about the file formats. I talked about SQL. That's something that pays off to learn because it's not just because of that, because it's not just part of the Google Cloud infrastructure, etc. If you have at your university, at your research institute, you have a server, you probably can access that server using SQL locally. And SQL is a standard, so small varieties of it will exist. But if you learn one, you will mostly be ready to use all the other versions of it, Microsoft, Boland, etc. And I showed you the steps of doing some of data pipeline. So I showed you a simple file, showed you how to upload that file and do simple queries on it, and also presented some suggestions on queries. And then I showed you the public data sets that we have access to. I asked you to try at least to go to Google BigQuery with an account created by yourself, a project created by yourself. Then you go to our project. You can see, even though you're not part of our project, you can query the databases that we made public. Of course, we don't make all public, but you can query using your project as the pay-in part. Then I showed you fundamentals of SQL, showed you the join, the group by, the basic applications. Then, with all that in mind, we made exercises with OpenAlex, which is the largest scholarly database we have around nowadays. It is free. It's free open data, but it's very hard to use. If you go to their documentation, it's hard to use because well, it's huge, and you have to have a large copy of it installed. Of course, now they have since last year they have an API, but you all know APIs are limited because you have to know exactly what you're looking for to really conveniently use the API. You cannot do exploratory analysis and you cannot cross data globally. So having a copy of it, it's very useful. That's what we did, and we made it public if you want to query it. And we did that in last session. I showed you these queries. I showed you, try to explain all the details of how it worked of these steps. I showed you how to run queries by looking for a specific paper, looking for a specific author, looking for a specific institution, and also made some aggregations to count for works, etc. Then today I'm going to focus on two other things. One is our work with Cielo, because it's mentioned in our program, and also to show that it's possible to integrate all that with Python language. With your own computer, if you have Python installed on your computer, you can query BigQuery. As if you're used to use R, it's also possible. You can check in their documentation, but here we focus on Python. You can with your computer do that, but the easiest thing for us and in general is to use collaboratory notebooks, which is a programming a programming framework, a programming tool that's part of the Google infrastructure. So if you have a Google account, you can use it, even if you're not paying for anything. You have access to virtual machines, simple ones, and you can run R and Python code. And with that, it seamlessly connects to BigQuery infrastructure. And so I will then, for the start things off, I will repeat what I did to you, but inside the collab things, inside the collab as a tool, to connect to BigQuery. So if we take, for example, the training session, just a moment. So for example, if I open a notebook like that, if this is the first time you try to do that, you just have to go to collab.research.google.com, right? And being connected to your Google account, you will get into a new window. Probably, let me show you, new notebook. You will see opening a window, but it will ask if you want to start a new or if you want to start with a certain template. In this case, they always go because I configured it starts a new notebook. And the notebook, you can mix text and code. This is the concept of they call literature programming. It's the Jupyter notebook, as I told you, but implemented inside the Google infrastructure. So here I run, this is a code that I run to connect to Google Drive. This is not mandatory. We do it if we want to access our Google Drive contents, files, to collect files or to save files, etc. But this is necessary to connect to BigQuery, this authentication part. Okay. So from google.collab import auth.authenticate user print. This print authenticated is just to so you can show it finishes. So probably if you are familiar with Python, this is easy for you. If you're not, but you are familiar with any programming language, you will see that this is your important modules or libraries, so people calls. And here we have this thing they call magics, a very poetic name, that you type two percentage signs and write BigQuery. When you do that inside Collab, everything that you write in the next lines will be queries that will be tuned to BigQuery. It will be seamlessly transported there, calculated there, and the result will be outputted here. You just have to pass, if it's not implicit, the project that you are using. In this case, I have the authorization to use Insys project, but you probably have your project that you will create. It will be here. If you create a new project, it will ask you for a credit card. You remember that the first time you use this, you have $300 as a bonus to use and to test. And then you will select the project you already built, and you check if you're connected to your project here, right? If you type in this, you will see you can add, you will see our project and the public databases from our project, but you can find uh, other things. You can find other contents if you click add here. You can look for data sources, public data sources, from by querying here. So so if you go into the Colab, you can type in every cell, you can type in your Google BigQuery query, right? And then you run, when you click run here, it will be run there and the result is outputted here as a table. Let me show you how it works. I will run this authentication step and then it's connecting. It means it's creating a virtual machine for me to use. You always be aware of that. It will ask if I allow my authentication to happen in this environment. I will allow. I will check allow. Great. You'll be always conscious of the amount of space and memory you have here. You see, you have to 12 gigabytes of space and nearly a gigabyte of RAM memory. This is important because if you're importing things from BigQuery, things can be hard, they can be large. And besides that, you have to be conscious of how are your queries because you can run queries that will output the result here and will be copied here, and you can run aggregations of queries that will output only the final results here that can be useful. So if I run this query, I am looking like we did in last session. I am looking in the works table for a paper with the DOI like this. Just to make things nicer, I will move it to the newest version of OpenAlex that we already have because I have updated. And I run this. It's in Syspo, it's public, the name is public DB, OpenAlex. Then this query is run in BigQuery and the result is returned here. Okay, it's just one row because there's just one work in the works table with that specific DOI. If I try to look for the paper title, again, select everything. You now know this means all columns. You can see that now I am doing exactly what we did in the last session, but I am doing inside the Google Collaborator instead of the Google BigQuery interface. And you see now I'm looking inside that database where title is like networks of international collaboration. I choose not to type in N to consider capital and non-capital letter, but I only found one paper, I think, with that amount of text matching the title. You see, networks of international collaboration. Here it is, and I have the data in that table, right? And this is mostly what we did. For example, we did the exercise of searching for Sandra Liebenberg, also here, and I found all this variations of name. And then I showed you, let's look in the newest version because they did a great job in disambiguating authors' names. So probably I will not find several of them. And also the works count is not works, is not a string, is a text, is a number. So you have now it's just one, you see. Sander Liebenberg, 453 works. She is from South Africa. I don't know which university, we can check. The national institution has this raw. We could check that inside OpenAlex itself. Which institution is that? Okay. So I think I gave you the idea. This notebook has an easy link that you can test it yourself and run when you're exercising up to now. Does anyone has a question? Anyone have a question? No? Okay. So if you go on here, we are just repeating what we did in the past. Okay. And like in the last session, we count publications per institution and we filter institutions by time period, all that. We did that. And I think you got everything right. Now I'm going to present another thing that we did is Cielo, right? Cielo is mostly Latin America, but not just that. Let me call it Global South Digital Library. It's more than a database, a scholarly database, because it contains and hosts the full paper in has some strict rules on open text and open access, etc. Well, the problem with Scielo, like many other local databases, problem is it's legacy work. Much of it's not structured. So if you want to work with it from a scientometric perspective, you have to organize it, and that's heavy lifting work. Even for a small database, Cielo has around 1 million works, and compared to OpenADX, that's not a lot, right? OpenADX has more than 240 million works there, but still, it can get tricky because it's like 1 or 2 gigabytes when compressed. So working with that is not for everyone. Let's call it that way. And also, the database is not structured like it happens with most databases around. We have this is a notebook that presents our work we presented at the STI conference and in a conference in Brazil. So we show here how we have collected the raw metadata from Cielo and made it into a relational model that everyone can use as a global. And we made it public so you can query on it as well. So here we have put in a notebook combining Python so you could plot things, etc. But most of the organizational code is in SQL. So what we had is we have downloaded everything. This is a sequence of steps that works for everyone, right? So you can do it yourself. We have downloaded the whole file up to Google Cloud Storage, and then we all the files were XML files. We converted them to JSON files, which are equivalent in a mathematical sense. And with the JSON files that we have collected, we can extract the metadata because we could have something like this. We have the Cielo here. It's even public. You can check it yourself. Cielo works, you see. This table, Cielo works. I invite you to check it now if you already have created an account for you. You will see the preview. This is how we have uploaded it. We have uploaded the way it was. This is JSON entries directly converted from the XML entries from the raw database. So every row is a work, but it is in a messy way. I mean, it's not messy for them, but it's messy for us to make scientometrics on it and to make any other global scale analysis. If you want to check how it works, and that works for every JSON file, you can collect the whole entry, for one example, the whole entry, and you go to the internet and you look for a JSON formatter or JSON viewer. You can find online tools like that. You can find not online. I paste it here. I click process. Well, this one, you see, it organizes the output for me. You see, so it organizes in the way that I can see. Oh, this is the affiliation. This is the institution. This is the publication year. And these are the authors. This is the abstract. These are the keywords, and all the metadata are here. So our job is to transform this into tables, right? Is to transform this to make it into tables so we can query them, so we can analyze them. So one way to do that is you use this statement JSON extract, and then I study how the JSON is built, how it's constructed, which kind of fields it has, and what kinds of field names it has. So I can find where is the author, where is the title, where is the publication year. And by looking at it, I can see, okay, so back at the beginning, so the journal title is here. It is inside journal title. It's called Epidemiologia e Serviços de Saúde. Is inside journal title group, which in itself is inside journal meta, itself inside front, and inside article, that's inside articles. So the sequence was not, it's like the legacy thing they have. And I can type in all those names as an address inside the JSON. Then, for example, to get the title text and the journal text, I would do that. to get, in this case, if I wanted to get just, for example, just the DOI, I checked that the DOI is inside article, front, article meta, article ID, and in the first position, counting from zero in the text. This is the DOI. And then sometimes it comes with double quotes. Stream is here to extract the double quotes around it. And then I create a table using that. That will be enough for me to see the file. Then project DB, the resulting table, Scielo, is this. I create a table where I have the ID, the DOI. The first ones are messy here. Where I have an ID, the Scielo ID, I have a DOI, I have a publication year and a collection, for example. This is a very simple table. I was built in this notebook just to investigate its presence in other databases such as Scopus and Dimensions and OpenAlex. So it's a simple table just with the year, the collection, and the DOI. But I could collect more things. And there's a kind of step that you can do for several databases. They are organized like this. You can create commons such as that and try to extract information from it, right? And then you can do size statistics and you can do trends statistics. You can analyze everything because you have, and here I use Python to draw. It's not our purpose to teach Python here today, but you can use any other tool like Excel, like R, to draw back again the tables and the results that you get. So in this case, for example, I use that table to see the trends in time, publications along the time. I collected from that table that I created the publication year, the DOIs, and the IDs. And I counted them using select pub year. I counted distinct ID, distinct DOIs, and I ordered it. And then I have this table. It's how many works the Cielo has and how many DOIs along the years, right? It started around the 90s, so it's natural that it's like that. And you see there's a margin of DOI still missing. Of course, we have a further study showing that this is not equal among the collections and among the countries. Also, if you exclude all the things they are not articles, editorials, letters, etc., you will see that it's slightly better than it shows here. So, if you are following me, I will try to see if you can, as an exercise, because this is an exercise that will be very common. You will see how to rebuild a portion of Cielo. So you have this public DB dataset, Cielo here. Let's pretend I have not did this work. I've not done this work. Let's pretend I have it raw. So I have this public Cielo, I have the Cielo works table. I want to output its, for example, its titles, right? I want to do that. I want to create a table that will output the title, for example, and the publication year. I want to study that. So I go to the preview. I have explained you. Now I'm going to show you what I did, right? How we did in the beginning. So I can take randomly. I will choose further on to make more representative. We'll take one entry here, and I will study it. We'll see. I will put in this formatter. Process. This I'm doing just because it makes my life easier, just because I can see it uh, more clearly about the article. So where is the title? Okay, the title for the article is in article meta. Then you have article categories, and inside article meta there is, or you have this title group, and you have article title, and inside article title you have the text, which is the real title. In many ways, there is a translated title group, in this case in English, because sometimes you even have the full text in two languages. Okay, but let's try this. Let's try and do this. I will query this table from Scielo Works. I will not limit it. And since it's a work full of JSONs, I will use JSON extract. I pass the value JSON extract, pass the value of the column. In that case, it's just one column, and it's called work. And between quotes, simple single quotes, I will type the address. Articles, article. I think it's title group. I am not sure. Then I'll run it. And what is it doing? It is looking through all the Cielo works table, the column work, okay, and looking for title group. Well, it's not title group, the name. That's why I got everything null. But inside articles, you see you have article. You can hide and show using this click. That's why these tools are interesting. You have articles and then article, and inside article, you have article meta, because in the front, this is the front material, right? The back material will be the references and etc. So inside article, you have article meta, and inside article meta, you have title group. Then I'm missing article meta here. Article meta. I run, and I'm running through everything. It's always interesting to do this translation of a raw table with JSON with this hierarchical format into tabular format. That's more interesting um, because that way I create tables. They are they are easier to query, and also they are cheaper to query, because when you query in BigQuery, you always collect things in memory by column, by the column. If the column contains all the information, then you are suffering from such a problem, because you all the time will be loading the whole data set. I am missing something here. Let me open the article meta. Let me just open the. I'm looking in the wrong data set, I think. Just a moment. Anyways. Okay, just to show you again, this is the relational model we want to produce. Out of every entry, I extract the work, the information for the work, the information of the keywords, the journals, the reference, the authors of reference, the affiliations, the authors, the abstracts, and the subjects. So when I do this, when I run this, I create this set of tables, right? That you can check in our publication. But in the end, I run codes like this, where I create the table from this raw initial table here. Scielo works corrected. Why have I opened the Google BigQuery? Will be easier to show you exactly what the table is. This table, like we are doing here. Like if I want to catch the journal ID, we'll do this. Um, Okay, so what have I did here? I have collected from all the Scielo works the journal ID, for example. How did that work? I have this table of the raw Scielo works, one each row, just one column, collected in this shape, right, that you have just saw, that I have collected from the link. And I try to look inside each one of these fields for the field I want to collect for every column. So here I have. I select JSON extract is a command that serves the purpose of collecting, creating a column. So just like I did before, every JSON extract here will be a column. I select from the column, pre-existing column called work, and here I pass on the address, right? Inside that JSON item, I want to go inside articles, inside article, inside front. This was our missing, okay? Inside journal meta, inside journal ID, I have the field text, and then I will call it, I will give it a nickname like we did in last session, journal ID. And then it goes through this address inside the JSON in every one of the rows of that table, Cielo works. And for every one of these rows, it will extract this address and call it journal ID. This will give me this table, you see, with all the journal IDs inside Cielo. Now, if I am annoyed by this double quotes like I was before, I could use the trim function. It's not that important. Trim serves to exclude in the beginning and the end some repetitive characters. So I put double quote as my problem. And if I run again, I no longer have double quotes. And now I can start building on this, right? I can start building on this again and again and again by adding new columns. And the full work of this, the result of this work, for example, if I want the publisher, the ISSN, the journal title, I am collecting the journals. If I want to collect the works titles, here it is, the DOI, the type, publication year. Here is the title. See, the problem of the title, and this is a problem that happens in several databases, not just Cielo, is that sometimes the title is in one field, sometimes the title is in another field. And I have collected all the fields I found where title is, and I put them together so I can coalesce. This function coalesce serves the purpose. If I have several inputs, I will take the first one that's not null, that's not empty. So for example, if I take this one, this is one of the versions where title is present, and I could add this as a column. Of course, I only got this by studying the XML and several versions of it. So I'll add JSON extract. I will extract from column works, and I will call this title. Right? Well, I'm doing in the wrong. So I have JSON extract, and I'll call this title. If I run this now, I will have created two columns. Right? I have to create one column called journal ID and one column called title. You see? So for every row representing every row of the original table, Cielo works, I have created another row with the journal ID from inside that was collected in this address and a title collected from this address. Again, I have these double quotes. If I am concerned about this, I can take it off using the trim function. and I run again, and everything will be fine. So this works sequentially. Apply it sequentially once, and again, and again, and again, and again. Will create me the table I want in all the tables I want, right? So this is very, I think this is today the standard procedure. I say this, it appears to be light, but I say I'm not saying this lightly. This is industry standard procedure to structured, unstructured data. So in several areas, in several companies, they have to deal with unstructured data collected from web pages, collected from mobile applications, collected from forms that people fill in. So they have this messy databases where every entry is a JSON in the way that it's a list of value, field name, field value, like I presented you last training session as a file format. You have this, then you go to a tool like BigQuery or like Amazon Redshift, to a similar tool where you have an SQL interface with an editor. You have tables where just one column or few columns are structured like that. They are JSON with field name, field value. And you run statements like this to build more structured tables where every column is just a single element of information. In our case, journal ID, title, and then author, and then publication year, etc. Then you can create a data model. That's what we build here. So in the end, by doing this repetitively to all the possible interesting fields that we have inside Scielo, we build this. So every one of this is a table where I link things one to the other by IDs or by indexes. And the code we did to run this is just behind. It's code that we run inside BigQuery to build those tables. And then after that, you create a data model for Cielo that's here. I will show you project to be Cielo relational model. And here are the tables that we have created for Cielo. So now we have something similar to OpenAlex. I have a works table. I can preview. I have the ID, the DOI when it's present, the title, the language, the type, the journal ID, the publication year. And then I have the abstracts for everything, and the abstracts is matched. I have a separate table for abstracts because there can be two, three, four abstracts for each work in different languages. Now we have the language ID, the work ID as stated in Cielo database, and the text for the abstract. You see that this column ID matches this column ID in the works table, so you can join them or combine them or group them in the way we did last training session, just like we did in OpenAlex. Then I have a works affiliations table where I have the uh, for every work I have an author and which institution it's placed. I have a table of authors. I have a table of authors of the references. I have a table of bibliographical information, so collection, publication month, value page, volume page, issue, when that means something, right? Today, some journals are focused on the digital thing and they don't have a first, last page, and they don't have a volume issue in many ways. I have a table for keywords. I have a table for all the references, which look very much like the table of works, but they are less rich because not always you have all the information. And I have a table for subjects, you see. And this was all built by that procedure. As I show you a very simple example, very hands-on example, how I created a table of two columns by structuring from the unstructured original data set that I have. And just the accumulation of the sequence steps creates Scielo for us. Okay. No questions up to now? Everybody's getting what I say. Victoria is
For
going
those
to say
for
something.
those
No.
who have just joined us in the session, I remind you that you can ask Alysson questions, opening your microphones or writing on the chat box. Okay.
Yes, I have suggested, advised you to try a little bit from our last training session to our advise you to try a little bit with Google BigQuery, try with the free tier that they have when you create a new data count. But if you haven't done it, you can try afterwards, of course. But I'm focused here today on showing you exactly how I did this organizing work in the case of Cielo, but showing it that it's a very broad example and a very archetypical example because and many databases I see around, not just Cielo, in many countries, they are organized like that. They are organized like XML or JSON files running on Mongo databases or something similar to Mongo, where you have the information unstructured and you can load it here like we did, like we describe it here, and then you start building the code. All this code is here so you can rerun it yourselves, but that's not the point because it's just a documentation thing, because you can use the tables that we made public that connect all the Cielo works, right? And our plan is keep doing that for other databases as well, for other global south databases at least. So if no one has question, I will go on with my examples, right? So here, by running this the set of statements that I exemplified here with you, you see, if I go investigating, and this is a trial and error exercise, right? And not just trial and error, but also iterative exercise, because I build a table, I add these four columns, and then I notice, I would like to know the collection. Then I go inside my JSON file to see, oh, where collection is written. So what is the field name and what is the exact path for that value inside the JSON. Then once I locate that, I can type in the full path here and output it as a value for the column in when that row gets processed, right? So and that's how we build things consecutively. And in the end, we'll go building the table. So this is the table for the journals, and then we have the table for the works, and then we have the table for the bibliographic information. And here at the end, when I create the table, I always collect the column names that I have created, table for abstract, etc. And after that, I started doing some global analysis of it, because that's what we are here for. And then now, since we have everything in our database that can be queried globally, we can do some other scientometric research on that. For example, I have collected data on the works, you see? So now that I have a table called works created by the procedure I have just showed you, I could count the number of works with UI, the number of works that has a title, sometimes title is missing, the number of works that has a language, a defined type meaning is a research paper, is a review paper, is it an editorial, is a letter, etc. And how many papers has a journal ID and a publication year. And by showing that, we see that database is mostly filled except for DOIs. You see, so you have it's around 1 million works, and from this million works, that's total, we have nearly that of everything. So nearly every work has a title, has a language saying what language it is, a year presented, a journal associated to it, but not so much DOIs. This is our main problem here. If I run, and this is the funny thing about the integration inside Collaboratory. You see, I have run a select statement inside BigQuery, and I just put here a table name between BigQuery and the project name. And the output is outputted to a local Python variable, a pandas data frame. If you know Python a little bit, pandas is a module to treat tables. Data frame is their technical name for a table. And it outputs this table, okay, which will be, if you just queried this inside BigQuery, you would see the result. Okay, just queried it in here. Scielo, I'll take journal ID because now it's in another place. You see, then I have the answers for that. But then inside Collaboratory, I could have it as a local variable, and I could use Python's tools to plot because I like plotting with Python. But if you use, again, you could export this to Excel very easily. Inside, if you're using just BigQuery, the results could be exported here, save results, you see, since it's a small table, to CSV, to JSON, like we saw in the last training session. And the results can be outputted to any other tool, but here I'm using Python's plotting tools. Then again, I tried to do this investigation on other types, and I created a table for the metadata that's present according to the collection. So because Cielo has collections mostly related to countries, so there is a collection for Brazil, for Mexico, for Argentina, for Chile, but there is also a public health collection. So in this case, when the collections are not for the countries, they have some overlapping, right? Some works are in two collections because one is the country it belongs to, the other is this special collection. But then I could see the differences in the presence of the metadata, especially DOIs, because DOIs are the problem, right? Most of things are filled like we have just saw in this global table, this global plot. And you can see some countries have problems getting DOIs, like Venezuela and Cuba and Bolivia. But most of them are more complete. So I also show the presence of, by the way, this table is the number of works that contain that information. Okay, so this is the number of works in the collection Cielo Brazil. This is the number of works in the collection Cielo Brazil that has a valid non-empty DOI. This is the number of works in this collection Cielo Brazil with valid titles, and the number of works from the collection Cielo Brazil that specify its language, because it can even be more than one, and journals and publication years and times. You see, for this and this is even 100% because it matches, and this it matches the number of total number of works. But for DOIs and titles, some problems may appear, and they appear more in smaller collections. So this is the kind of thing that I can do to also analyze the quality of a database and the completeness of a database. If I go on and I do that to, for example, abstracts, authors, I can see, for example, the presence that the number of works where there is an author and the number of authors. I can get the most prolific authors, Deborah Carvalho Malta, Edson Marchiori. You have a certain number of empty authors, certain number of works. It's not large, but it happens. But then you have the names that appear the most, exactly the same. You do here. We are not considering ambiguations of names. For example, if Deborah Carvalho Malta appears Deborah C Malta in another work, I am not getting it. I mean, I am getting it, but it's counting as a different person, right? In this query, because I am grouping by the exact name. Of further work that we are doing now, and it's very good exercises to look for all the disambiguation methods, or to look for a database where disambiguation already was worked out, for example, in OpenAlex, and bring it here to match the alternative names for the author. And then I will probably have a larger number of works here in Deborah Carvalho Malta, right? I can have the works with affiliations. For example, if I count, let me describe here so I can make it clear what I'm doing. I wanted to see how good is the coverage of affiliations inside Scielo. So what I did, I went to the works table, and inside the works table, I counted how many works are there. I counted distinct IDs. I count how many affiliations appear. I will not count distinct because I want to know how many affiliations, how many relationships between author and institution there are in the database. But if, of course, there will be repetitions of institutions, it's expected. So I will have also countries, how many countries appear. And I narrowed this down to research article and review article, which are the two types more interesting, because an editorial not showing all the affiliations, it happens, or not showing the country, it happens. So I did this and I plot the numbers. So when I narrowed down to research article and review article, the number of works comes down to 721,000. right? Right. And the number of affiliation of works with a number of affiliations in total is 1,700,000. So it's a little more than two affiliations every work. So every work on average has around a little more than two institutions affiliated to others. And how many countries is a little less. It means not all affiliations indicate the country of affiliation. That is not a problem, in fact, because usually institutions have a name and they exist in one single country. So by the institution's name, you could, uh, like say, hydrate the data with the information from the institution's country, right? So could also count the countries and the number of institutions affiliated in each country here. So how does that work? I will count the institution and see the country, and I will group by the country. Now I think if you got the idea from last training session, you are now able to understand this query or even build it yourself. Let's just repeat what I was telling. I have collected from the works affiliations table from the Cielo model I created, right? Works affiliations table. And then inside the works affiliations table, I will also join with the works table to collect the, uh, the category of the work, the type, and just to filter by where B type is research article or B type is review article. You do remember then when joining, I have to pass the index. In that case, it's work ID. It's the ID for the affiliation and the ID for works that I have to match. And I will group by country. And then I will count the institutions and the affiliations. Then we see it's not ordered, but you can also see the ambiguities that exist. So Turkey has 13,800 institutions. Mexico 74,800 institutions. At least different in uh, different affiliations in that institutions, not number of institutions exactly. To get the number of institutions, I'll have also to make it distinct by count distinct here, right? And I put in then here you also some affiliations don't have any institution marked, right? Some authors don't have any institution marked, and you have your ambiguities like Brazil and Brazil written with S and Z. You have, for example, Argentina and República Argentina. Czech Republic is there once, but the other institutions not may have some other ambiguities as well. But let's do this exercise here of now changing, and I will just put a distinct name for the institution. Let me say you have the institution. I'm using the works affiliations. Let's do this exercise. Rebuild this query, okay? Just so you can understand. Of course, the code is here for all the solutions and everything I did. You can query because this is public, but I want to rebuild with you so this become more interesting, more interactive, right? So let's say I want to find out how many affiliations are there in the Cielo database, the way it is built for each country, right? Suppose I don't have this. So let's study what I want. Now, after this first step that I have Cielo built around a relational model, so now I can look at the tables. So I have the works table, and I want to filter them only by articles, only by research and review articles. So let's build that. In the works table, I have the type, right? I can even count. Okay, let's try to do that. Select from I will try where type is review article. How do I know that this is a valid name? I know because I saw in the table. Okay. Because I studied the data a little bit, and I see the types, the possible types. If I'm unsure of this, I could group by type and see what types they are. Okay, so let's do that. I will do the following. I will do the type, then I will count IDs, distinct IDs. I will group by type. And I will order by this distinct ID thing. Say n works. Then I can see the most relevant types. So order by n works descending. So by now, I suspect this is already familiar for you, okay? But then what I did, I've been inside my model for Cielo, and I have inside the works table, I have grouped all the works by its named type. So you have the first most common type of work is research article. The second most common is editorial. Third most common is case report, etc. Then you have review article here, rapid communication letter. You have a certain number of undefined types. But since here we are, let's say we are interested in research results, so we will take review articles and research articles. And now I know the name. Okay? Then, since I know the name, I will try to collect the works by filtering this too. So select, let's say everything from that database where type equals or for that query, I have a list of all the works like this. What I wanted to do, I wanted to see the affiliations, right? But then, if I want to see the affiliations for each countries, I have to find this. This is another table of our model. This is in the table works affiliations. Let's study this table, works affiliations. Where I have the ID, which is the ID for the work, and I have the country affiliation. That's what I wanted, right? If I do the preview, not all of them I have an affiliation, but I sometimes have the institution, not the country. But then I want to count this, the affiliations each country. Okay, so I have to check the following. I have to join. So I'll create here a name. I will call for this table. So I will use this name as an alias to join to another table. You're probably already familiar with this joining, like we told in the last session. We'll call this affiliation. Remember, when joining, you always need an index, a non. So, of course, I want to link the work. Okay, now, what have I done here? I have now the link between the works and their affiliations. And now I could even plot them. Let's say I could plot the ID and from the first table. So I will put the name for the table, works.id, and I could put the country affiliations. In this new table, the number of rows is no longer the number of works, right? You understand this now? Because in the previous table, like this one, the one that was here before, I was just querying works. Now I am joining with affiliations and I'm showing information from one table and for the other. So every time there is a match in on, every time there is a match on, there is a new row in the resulting table, right? So the resulting table here contains a new row for every combination of work ID and affiliation country. So for a country with three affiliations, for a work with three affiliations, there will be three rows in the resulting table. Okay, just for you to know that. So if I run this, then you will see the resulting table. You see that it has 1,400,000 works. You see it's larger than the number of works in Scielo because of that reason. But here I mentioned, see, this work has some affiliation with Republic Argentina. This work has affiliation with Morocco, Algeria, and Morocco again. You see? Now, but I have repeating, I want to collect the number of affiliations each country. So what do I have to do? I have to aggregate, right? I have to count. If I want to count affiliations, I'll go for that. So I'll count how many are there when I group, and not forgetting that I'm always filtering, I'm always considering only the research articles and review articles. So I will group by affiliations country. I would have to give a name, otherwise you will name something strange. And it's usual thing that you put the aggregations in the end, just to make it easier to read. Although it's not so necessary. I will count this n. I always, not always, but I have tendency of putting in different rows. If you put this comma in the end, there's no problem. Not so long ago, you could just put commas in between the columns, but now you can put at the end, so you can have many of them and not forget about the comma. Okay, so then I have to count, and I will order by then, because it's a nice thing to see. So order by descending, so I have the largest on the top. You see, so I have Brazil. You have many affiliations without matching the country, like we even saw that in the table. Sometimes you have the affiliation, because the table affiliations will not have a line when there is an author without affiliation. It will always have a line only when the author has an affiliation. That's the way we built the table. But sometimes you have just the institution name, like we saw here, right? Like this case, it has just institution name. That could be hydrated, as I told. That could be filled if I look somewhere where this information, where this institution is. But now I'm working with the raw data for now, and this work of complete data completion is a sophisticated thing. Is a research in itself, right? And it's heavily depending on what you are doing and what you want to achieve with that. So now I get the number of affiliations. It may be the case that I don't want the number of affiliations. I want the number of works. So I will not count all the rows that contain a work ID. I will count distinct work IDs. So I will force them to be non-repeating. Now this is a number of works. See, quite a different number. Does anyone has a doubt? Do you follow? No masses on chat. Okay, go back where I was. So let's say I want to avoid these things of new countries. It makes no sense. I don't want to see them. I know there are some of them, but I will hide them because I want to really talk about the countries where I know. Another thing is that when I do joining, usually I select the column for everything to make it clearer. But here you see, I have not explicitly wrote where this type column comes from. It can infer, the query can infer the type comes from the first column because there is no type column in the other columns, in the other tables that I have joined. Okay, so it's working because of that. But sometimes it's risky because you have similar names sometimes in columns. To make it clear, you could do that. I could also add, like I told you, another. I will put in parentheses the or thing because I want to be sure the sequence of the logic operation. I want this or to be done first, and then end country affiliations. Country is not moved. Okay? Just so I can see only the real countries. Affiliations. All right, I'll select this. And I can start trying to join, right, countries' names to replace them to if they fit. In this case, countries is not such a large set. Right? Even some people put beer, beer instead of Brazil, right? This is will come from Brazil too. I think some people must have put EUA, Estados Unidos da América, or other people put Estados Unidos, other people United States of America, and there will be US as well. And you could coalesce all those names into one. That's the case. But now you got the idea. Up to this point, I tried to reproduced the reasoning I made to analyze the relational model we built for Scielo. I can now, it's only possible to build this kind of analysis, this kind of plots of understanding what are the most important countries in the Scielo publications because we have a working relational model and we only have a working relational model because of those previous steps I have explained. I have showed a small example of extracting columns from tables. Any questions up to here? Very quiet and no message on the chat. So I will move a little bit on. I was expecting you to ask some things, but you're a little shy. Okay, let's. I will try to reproduce another. Here we have reproduced this work, right? If I wanted, for example, to try to see the most present institutions, right? The most present institutions inside Scielo database, which one that would be? Then, well, if I'm looking for institutions, we have a table of affiliations. What do they contain? Oh, they contain the institution name, right? It's funny thing now because you see this Connie set, an easy, direct way of data completion in this case would be if the institution already exists with a different name, we can copy that name for the country. And for example, now I know that this is counting null, but it could count Argentina, right? So, but let's now talk about the institution. If I wanted to identify the most important institutions in Scielo publications, how would I do, right? Well, first I could go just to that table, but if I want to narrow down to research articles and review articles, it would be good to join the works table again. So let me do the same thing. I will copy this. So I'm going to select something from the works table. Okay. And I would join with the affiliations table. Now I can select the institution. So in the table affiliations, I can type in the institution and I will put in the other row. I can count even do it by counting the distinctive works. I want to say the number of works in the institution, not the number of affiliations, because if I don't put this distinct, if two authors of a work are from the same institution, that institution will count twice. So it depends what I am really asking. I'm asking the number of affiliations or the number of works in that institution. So select affiliation institution, count. What do I need now that I'm trying to count? It is an aggregation. I need a group. Right. I will give a name. You see, it produced F0 underscore. It's a standard name, F0 underscore, F1 underscore, and so on, when you give no name for aggregations. And I will give a name, call it N. The N will not change a lot that I see. So the most important institutions, Cielo, Universidade Federal do Pará, Universidade Estadual Paulista, Universidade Regional de Blumenau, UNS, USP, and then it goes the list of different institutions grouped by name. You do not forget that names are not disambiguated. It means I can have slightly different names for the same institution. This is a thing that happens in all databases, even the commercial ones, and there is an effort that you're going to put to decrease the ambiguity, like all commercial databases also do. But this is in a very, very large data set. That's how it works. You always have a margin of repetitions that you do not locate. Either way, this could be better solved once everyone starts using ROS, ROR, right? Registry of I don't know, is a registry for institutions and universities that it's just like we do with DOIs that could do for the institutions, just like ORCID would work for identifying unanimously people who are authoring works. So by that, I have group by, and I will also order by and descending. Run it. Now we have a sequence of institutions by order. Now I know the most important. I was talking about the most important without ordering before. So now is Universidade de São Paulo, then Universidade Estadual Paulista, Federal de Minas Gerais, and so goes on. So this is a kind of analysis that we now can run on Cielo because we have built a relational model for it, right? And I am showing you now how to build these queries with it. And of course, I could have run it inside Colab, just like we're doing in this notebook. Any questions? So many people online. No? Okay. In our building, just going along our building of the Cielo relational model again, so you can understand the steps, because there will be the same steps and the same modeling for every for nearly every database that you find in structure around. I have an expectation of what I want to see, of how I want the tables to collect. Then I load the database. Sometimes I have a set of files with some corrections to make. I have isolated them and corrected them. In this case, I have used regular expressions in Python because in this particular case, I have a volume of files inside Cielo that they had a single quote instead of double quote. And this was a code aimed at replacing that. Then I combined the tables of the works and the corrected works. And then I even used regular expression to do some structural statistics. I mean, I wanted to know how many fields are there for an entry of a work. So if I take all the works in the Cielo database, how many combinations, field name, field value do I have? And then the mean number of it. So I have nearly 400 fields each work, if I count everything. Then after running this several times, I achieve a diagram because that expectation of diagram is how I start trying to build the tables. But then I look at the files and I see sometimes I have to change names of fields, sometimes I have to add fields, sometimes I have to put fields from one place to another, and then I get my final model. And here is the code to build all that model, to build every column as it is. And then I just show the column names. Now that we understood everything and showed some statistics, one good thing about having everything in this federated cloud infrastructure, one good thing about it is that now that we have this table, these tables for the model, and now that we have other global databases such as OpenAlex, if we have persistent identifiers, we can even join them across any dimension that we want to analyze. In our most obvious case, we have DOIs. DOIs are persistent identifiers. So I can look for papers in one or the other, and I can look for information in OpenAlex that's not here, and more often vice versa. I can information for certain DOIs. They are in Cielo, they are part of the Cielo library. I could have specific information that just Cielo has by joining them, and vice versa. Okay. So a test I could do, for example, is with the affiliations as well. How do the affiliations count in the OpenAlex and how they appear here in the Cielo? Let's study that. Okay, let's study that and to see. I will try to count for every DOI how many affiliations a DOI has inside Cielo. Then I will try to count how many affiliations a certain DOI has inside OpenAlex, and I will see if they match. And eventually they will match. Eventually there will be a mistake and they will not, and we'll try to see what happens. Okay, now I will build the queries for investigating that. Okay, and that's how we're going to finish the session because it will be a sophisticated query. Anyone has questions? I keep asking that. Oh, okay. So then let's see about the affiliations inside Seattle. Then I have already made this query. Already made this query. And I'm counting the number of works for your institution. Now I will do the following. I will do the work ID. I will count institutions. And I will not say distinct. I want to count the exact number of all those institutions' relationships. I'll call as insts, institutions, not being lazy. And I will group by works. Okay, so for every work, I will count how many affiliations there are, but institutions affiliated. To be to be completely correct, to be how many affiliations, because if I repeat institutions in the same work, I am counting them again. Okay, I could count the number of institutions by putting a distinct here. You understand? Let's do both. Let's first try to count the number of affiliations. Well, I've got it wrong. Institutions, institutions. One, So I have, you see, this is the work in Scielo with a larger number of affiliations for institutions. There's 106 affiliations. There's probably some medical or physics research where they have this association, several laboratories, and that's what happens, right? If I put a distinct, I will exclude those cases of several authors in the same institution, and I will count just the number of institutions uh, in every work. Okay, so now the most is 58, because out of that 100 and something, there was at least on average two people were from the same institutions every time. Well, now I made this bibliometric evaluation. I want to match this with OpenAlex. Let's see how good OpenAlex is in capturing this micro detail of the Cielo scientific production. Okay, but then I must have some persistent identifier for that to be possible, right? And we have the DOIs. I will match the DOIs when they exist, right? When they are possible. So if I were to do that, I will take the DOIs are on works table, right? Let's see. There is a column called DOI in the works table. So I can join again. I can join. I will call OA works, open Alex works. Then I will match from works and DOI. I have them matched. But the point is what I want to do with that. I want to do because now every time I match a work from one and the other, I am counting it again. I want to check. So this maybe I should do a intermediate step. It will be the best. I will first select the DOIs inside Cielo that also appear in Complex, and then I'll count the affiliations on that, and then I will group the two tables. That would be easier to understand and easier to do, right? So this is what we have done. Okay. If now I want to check which DOIs are in OpenAlex, DOIs from Cielo, so I will do the following. I will join this for Cielo. So away, away. I'm just not sure if that works finally because sometimes the DOIs comes the pure code. Sometimes the DOIs come with that HTTPS at the beginning. Ah, that's what happens. You see, the DOIs here don't have the HTTPS. So I have, and in OpenAlex, I know they have that part. I think that part is the first 17 characters, right? HTTPS double dot slash slash DOI dot org slash. I think it's the first 17 characters. So I will take the function called substring. It takes the first 17 characters. Oh, it starts at 17. Let's see. Select. See how many of them are. Let's see. Let's see. Okay, there are not so many, not so few. Okay, then for those DOIs, I will call this, I will give the a provisional name with this with statement. I will call aux, auxiliary, between parentheses. So this table is now called aux. In the code below, I can name aux the resulting table from this, okay? And then I will select uh, from the works in OpenAlex. All the way. I will join this aux. I've also joined to the affiliations table inside OpenAlex, right? Because I want to know how many affiliations. If I go into study, how OpenAlex is organized, I will see the table works. I think here it will be in works authorships because works authorships has an institution ID. So I will match with works authorships through the work ID. So I will join as. Oh, I'm missing. Then I'll ships work ID. Now I have everything joined. I have from the table works only the ones that are in Cielo because I have joined them always DOI, right? Because I have joined the DOI with the DOI selected from here. Couldn't I, instead of using aux, I could have just typed in all this here in the parentheses? Yes, I could, right? It's just make it more didactic, uh, clearer to read probably. Because here I'm just selecting the Cielo works and I have run this query here and I gave the result a name. Again, uh, I have now the authorships and I can collect now how many of them are. So I will try to do the auths.doi. I will try to count, right? I will try to count them number of institution IDs of distinct. If I want to do like in the other one. So I have the DOI and the number of institutions that are in each DOI inside OpenAlex. I will run this. I will order by as well. I have to group by and order by Descending order. And I forgot the us. With us. So you create this provisional name for a table. No data to display. I did something wrong, clearly. Let's do by part. This one had a result. This one had a few results. I just forgot to do. One thing sometimes that sometimes the UIs, they are case insensitive. I will put everything non-capital letters to guarantee. I mean, they are coherent from in one database, but not always coherent from one database to another. So I'll put this. Okay. And then I run now this simplified version because I don't know exactly what I got wrong. I'll just select the ID, open Alex, and the UI in both. Now here we have a problem. Probably I'm getting this wrong. Okay, join aux as. So my maybe I should do it directly. It's a sophisticated query indeed. Despite I did it before, sometimes you get confused with own code. This is the problem with live coding, but we will solve it. So I have this aux DOI. I have from open, I have this list of DOIs here. They exist. Okay. The next column is called DOI. Then maybe if I go straight to that instead of this intermediate step, I'll do the following. Go straight to that. Maybe it's confusing me instead of helping me. Okay, and I will join this the authorships. So also about Scielo DOI, join open Alex. I will put the open Alex ID just to check if they are both here. So I have the open Alex ID and the DOI. And now I will join with the authorships. Oh, it's I was that's the mistake I was committing. You see, I was mixing OA and OAW. That's okay. Let's do this. This way it becomes simpler. OA.id. You see here it was OA, OAW. This was mixing things. OA, OADOI, OAID. I will now put O ships dot institution ID. Run this here. So I'm joining works from Cielo to match them through the ID with OpenAlex, considering the two cases, considering the two cases, and considering also the fact that capital letters uh, have to be taken into account here. And the beginning of the DOI in OpenAlex, it has those HTTPS slash slash etc. I am matching this with by the 17th character. And then I have the institution ID. Now I want to count the IDs, right? I want to group by Cielo.voi, and I want to count the other things. Count distinct. We'll call as institutions. I will order by institutions. Descending order. Of course, I have to group by one more thing. That's OIID. I don't think it will make any difference. I could even take it off, but I will keep it because supposedly for every DOI you have this uh, single open Alex ID, right? Because they are both unique representing something. You see, now I have a list. It's you see, it's not exactly matches. I will take off this. I'll have to group it for it. And I will run again. So I have the DOI and how many institutions are affiliated in that DOI. I started with the largest, usually is a much smaller number, right? But let's now compare to what happens. Now I'll use the with statement because now it'll be useful. Because I did this for Cielo, right? I did this for Cielo. I will, instead of using the works ID, I will do the works DOI. I will group by them. I have several without a DOI. I will exclude them because without the DOI, I cannot match with OpenAlex. In this case, I will have also to write the sum in another way. So I have a work here. You see, it shows some works that are not in OpenAlex with a DOI. It's not the majority, but a few with several institutions. I think Cielo also has some DOIs that are representative of the abstract in a conference. instead of the full work. So it's natural that will be so many institutions in a few of them. And OpenAlex, I think, does not collect that, but this could be investigated if you just take a look to every one of these DOIs uh, in detail. But now I have these two tables, right? I can try to match them, at least for the part they do match, right? So this first table has DOI and institutions. I could select and join them. So I could select everything from this table. I will put parentheses here. I will put in a space just to make it as A, or this just A. I will say join. And have this whole table here. The width statement, but this will be nicer. As B on A.doi equals A.B.doi. Then I will show, and of course I'm going to select everything. I will select A.doi because they have DOIs in both columns. And I will have A.institutions as Scielo inst, for example. And I will do the same for B dot institutions. I am now joining two tables that were the result of all the joining. See, this can get as complicated as you want. But I think you got the intermediate steps mostly. Anyway, you have a recording to check for that if you prefer as well. But I was exploring all the details of what we did in this training session and the other, collecting everything all together in a single complex task. So you see, you have differences. You see, you have differences. So in some, this is something to be studied because they are not perfect databases, none of them. But I suspect OpenAlex sometimes messes things up, and Cielo is the library, it's the original place where the works were put online. So I suspect that that is the reference in any case. So, for example, for that particular DOI, Cielo points 10 institutions and OpenAlex point 8. It could be the case that OpenAlex is right and Cielo wrong. It could be in the case that the disambiguation of the institution's names is better done in OpenAlex, right? If they match to two institutions are different named with a slight difference because someone made a typo, because someone called University of Campinas or State University of Campinas in the same work, so giving them different names in the same work despite being the same institution, and then you could have something like this. But in general, what may be the case is that OpenAlex is just missing two. Then you have this other work, 9 and 8, then 7 and 7. You see, in this case, you don't have this works with so many institutions linked because now we are just collecting the DOIs that happen both in OpenAlex and Cielo, right? So, but they are clear. You see some of them, there is exact match. 9 and 9, 23, 22, and then it goes. And then as it goes, sometimes you have diff, distant match, sometimes it's very close, sometimes it's completely exact. And what we have here is 308,000 DOIs to be analyzed, right? I could even run some statistics now on which are the ones they match, which are the ones that do not match, what type of institutions are there, they are missing in one or missing another. And I can go evaluating this by taking the intermediate results from these queries or else creating new queries, collecting parts of it. Now you can work, you can elaborate on that using just these tools that I show you. And like I showed you, this thing of collecting everything in a notebook, you know, to in a notebook in order to get everything going, in order so you can get a history and also a documentation of what you are doing is interesting. This is, for example, the way we made public its code to organize and to make a relational model out of Scielo, right? For example, I am putting it here, and now it's recording as part of the query, and it can be run from here since I have the authorization. Okay. So this was a large query, okay, that we have built incrementally. Yeah, we built two simpler queries before, then two simpler versions of it. Then we have improved them. Then we have combined them to produce this final result that compares OpenAlex and Cielo in the coverage of the affiliations. But I think I have illustrated all the areas that we are discussing. Does anyone has any questions?
I was curious, Alison. I wanted to ask you. You mentioned you were working with other databases from the global south. Um, I'm not sure if you meant inside Cielo, like the examples from different countries you showed, or maybe another database apart
No,
from
we are now
Cielo.
trying to collect La Referencia and Redalic. We are to do similar work because they have the similar situation sometimes was. There's also databases from the African continent, but I don't remember the name now because we are still in the collecting process. Also, a very similar problem that is in the South Korean uh, databases where they have very similar format with Cielo. They only have a larger problem than Cielo has with the presence of the UI, with the presence of the UIs. They have even a larger problem with that. But these are the ones. Mostly, I was collecting just these days Redalic. Problems Redalic is not as rich in metadata as Cielo, and it's not so standardized. I mean, some of its journals are standardized like Cielo, like a portion of 60% of it around that. But it's not the full of it. Some of these journals are just PDFs and the metadata is incomplete. So you have some work to extract from the PDF thing that's missing. But this is the works goes in that direction. And but this intermediate tools where you have the unstructured data already at your hands, XMLs, ATMLs, JSON files, and you want to create tables. So then you organize a model of the tables so you can combine them and do queries like I did that you can really extract global information. These are the kind of tools that I'm trying to show for doing these intermediate tasks.
Great, thank you. I don't know if anyone else has any questions. So I just wanted to quickly remind you that we will be having this same course in 2 sessions next month in Portuguese. So let me check
Yes.
the dates. That will be next the 10th of November and the 24th.
Okay.
So if anyone has an acquaintance interested in this content in Portuguese, then we'll have that opportunity also in Yo Sigo Publicando. And well, this
I will speak slow Portuguese, so you can. Most of you that speak Spanish can follow.
well, I'll be presenting, but I don't know Portuguese, so I'm sure I will be presenting in Spanish.
Okay.
So this recording will be available next week, and we'll see you next time. Thank you
Thank you
very
very
much.
much for the presence.
Goodbye. Thank you.
Bye.
Gracias. Thank you.